So student go to the teacher's website for the chapter 7. Here this is a visualization of dataset. Our topic is the example 7-1 using CBOM module to display the iris dataset with the advanced visualization of multiple features and connect to the server first. And there are three common applications of visualization or in artificial intelligence. First is the heat map, the correlation map of feature column X. The second is pair plot for comparing the relationship between different columns. The third is pie plot, showing the distribution percentage of a specific column. Okay, first we will load the dataset first. Here is our data, and then since that we want to examine the relationship among variables, so first how to we convert the target label into number value. The method that we convert the specific label of here into the label, the numerical value, not vector. We use the label encoder method, and we convert to 品种值 here. And the third exercise is the quantitative exam. Quantitatively examine the correlation between each feature column and the target column. So we should to do of let us to do the here.
Quantitatively examine the correlation between each feature column and the target column.
The feature column and the target column. So here that is the quantitatively. Quantitatively is the command that to display the correlation value. All columns must be in numerical format. And how to modify the columns data type? We use of that. So the objective is to create a correlation coefficient. And first we will remove the space column, 品种. So we drop the space for the column. That is df2, right? And we show the df2. I think that here this is not correct. So I want to show of this, right? So the method 1 is use of that. First remove. No, I think that here is okay. Use this. And the result is how to interpret it, the correlation of features parameter. When the column space value is 1, the spectral length, the coefficient is here. That is high correlation. And for the sepals width, the correlation coefficient is here. This is the negative 0.4. This is the moderate correlation. And for the third letter is the petals length. Here letter is correlation coefficient. And for this is the 0.9. That is high correlation. I think that this is very high correlation. high correlation, and this is a moderate correlation. For the exercise 4, is use seaborne heat map to present correlation effect. We will draw the correlation coefficient gradient map, and we will compare two methods for presenting correlation. The A is use a regular table to display correlation. Second is use the visualized table to display correlation. And we have the parameter that is not. Is true will display numerical value inside each cell. And not is short for annotation, means notes and annotation. And not control whether annotation are added to the heat map. So here is like our command. Like here, we use the and not. Use heat map for this to show that the objective is plot the correlation coefficient gradient. Correlation coefficient gradient map. Okay, we will draw the map like here. And for the exercise 5, that is correlation analysis. Correlation coefficient analysis. To sort by space value from high to low. So the objective is solve the DF3 by space value in descending order. So we will draw this with the solve value by the 品种值 ascending, that is false, from high to low. Then we will transfer this table into the heat map. We will use seaborne to draw the heat map like here. Inside here, this is with the solar value. We will sort it by 品种值 and with in descending order. We will sort by 品种值. We are sorted by 品种值. The DF3 is sorted by 品种值 in ascending orders, in descending order, and with the annotation note, like here. So here that the DF3 is sorted by 品种值 in descending order with the annotation note. And for the exercise 6, that is correlation coefficient analysis. We will first sort it by space value from high to low, and then display data where the coefficient is greater than 0.6 or to smaller than negative 0.6. So we sort the DF3 based on space value and from high to low. Here that we sort the DF3 based on the space value and in descending order first, like here. Here that we sort the div tree based on space value in descending order. And then the second step is to query the high correlation coefficient with where the correlation coefficient is bigger than 0.7 or negative or smaller than negative 0.7. Like here, we sorted the div tree based on the space value in descending order, and also query the the coefficient correlation coefficient is bigger than 0.7 or the correlation coefficient is smaller than negative 0.7. Finally, we will show the answer is like here. And we will transfer this into the heat map. Use the seaborne heat map. And we will show this the query data like here with the annotation note. We'll show the result like here. Okay, student, here that you have the 10 minutes to write the program by yourself. Okay, here that we'll do the next. We'll show the correlation coefficient gradient map with the heat map. We use the seaborne heat map to draw this as this. Then we'll do the exercise 7. Plot the relationship among all columns in DF2 at once using a pair plot. The pair plot means in pairs. Pair plot means plotting data in pairs combination. For example, that here is our DF2. We'll show the pair plot. Here that is every variable compare the other variable. The variable 花萼宽度 compare the space value. So we will show all the pairs, all the data that is plot the relationships among all the columns. We will plot the relationship among all the columns. In DF2 Advanced, use pair plot. So we will show the plot like here. Wait for 30 minutes. Okay. 13. The Exercise 8 is the advanced pair plan application. It specifies only two feature columns. We will specify only two feature columns to visualize their relationship pair plan. Petal length versus the sepal width. The petal length versus sepal width will specify only two features column to visualize their relationship pair plan. Specifies only two feature columns. Specify only two feature columns to visualize their relationship. We will specify only two feature columns and to visualize their relationship. To visualize their relationship. Pair plan is the petal length versus sepal width. So here is visualize.
Visualize.
Where do of this is visualize. Visualize. To visualize, specify only two feature columns to visualize their relationship. For the petal length versus sepal width
Petal length versus sepal width.
versus 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 that is versus 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 versus. But if I write this, we pronounce as verse. Versus verse
Versus.
versus. But
Petal length versus sepal width.
versus. So that is called versus.
Petal length versus sepal width. Petal length versus sepal width. Petal length versus sepal width.
So we'll plot only the relationship between the petal length versus sepal width. And we have parameter called HUE that is different categories are displayed using different color. So different categories are displayed. Different categories are displayed using different color. 调色盘 HUE that is different categories are displayed using different color. The hue HUE that different categories are displayed using different color. will plot only the relationship between the petal length versus sepal width. And here the first letter is not correct writing for the to enlarge the map. For the pair plot, if you want to enlarge the map, you use the size. And we will do the sepal length to the sepal width versus sepal width. Okay, we write this and we'll fill in the blank question. Fill in the blank question. Fill in the blank. Fill in the blank question. Fill in the blank question. The upper right plot. Look at the y-axis. Upper right plot. Look at the y-axis. The petal length letter is okay. Upper right. For this. For this letter is the petal length. The petal length letter is small than 2. That belong to which flower space letter is belong to which flower. The answer letter is 0. Here 0. This color. He said the petal length letter is smaller than 2. It belongs to which flower space? It belongs to the flower space 0. Belong to the flower space 0. And for the petal length, letter is bigger than 3 and smaller than 5. It belongs to the flower space 1 for this color. And for the petal length is bigger than here 5. It belongs to the space, the flower space 2. It belongs to the flower space 2. For letter is upper right plot. For this letter is the lower left plot. Lower left plot. Upper right plot and the lower left plot. For the petal length, letter is smaller than 2. It belongs to the flower space 0. For the petal length bigger than 3 and smaller than 5, it belongs to the flower space 1. For the petal length is bigger than 5, it belongs to the flower space 2. Here is the fill in blank questions answer. And for the exercise 9, it's the advanced pair plot application. We will specify only one feature column for visualization. Here is advanced pair plot application. It specify only one feature column for visualization for the petal length. So we use the pair plot command, use the parameter variables for this, and we use the hue. The hue letter is the 2 display the category is displayed with different color. The hue the hue will show the different category. The different categories are displayed using different color. So plot only the relationship for petal length. The feature is that although there is only one plot, the hue palette parameter can be used to display three different categories color. Although there is only one plot, the hue palette parameter. Here that is the palette parameter. Palette versus palette 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 that is palette 调色盘 palette. For hue the hue palette parameter can show different categories. So the available parameter we only have one feature columns, and the hue palette parameter is the space can show the different space with different color. So for exercise 10, we'll plot the relationship between petal width versus space value individually scatter plot. We'll plot the relationship between the petal width versus space value individually scatter plot. Okay. Individually palette individually separately individually. We will do this individually. We'll do this individually. Individually plot the relationship between the petal width versus space value. Individually we'll use the matplot module to generate the plot. So we use the scatter command for the two parameter to individually plot the relationship between the petal width versus the space value. It's like here, individually, and we also use the hue. The hue will display the different categories with different color. And here that is advanced plot application, where displays only two columns, petal width versus petal width, and from DF2, and add regression line. Here that we will add regression line. So the objective is display only the mutual plot of two only mutual plot only of the two column pairwise versus pairwise in depth 2 and add regression line. The first one is display individual regression individual regression line. We'll display the individual regression line. The individual regression line. We'll show the individual regression line. And we use the parameter is kind is regression. And also the hue, the palette, 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 palette. The palette parameter will show the different colors category. Here is hue palette, and here that will show the regression line individually. And also here that I want to know the other one is the
Mutual plots.
mutual plot. Mutual plot. Mutual. 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 Here that is the mutual, individual and the mutual. We will only the mutual plot of the two column. 相互的，互相的。Here this is a mutual plot. Here this is the individual. In the individual's plot, the mutual plot, the individual plot. Okay, student, now you have the 2 minutes practice of this plot. Mutual plot, individual plot. Mutual plot, individual plot. Mutual plot, individual plot.